Hello everyone and welcome to back to Winter Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Sridhar, a lead data engineer, joined him as he uncovers the exciting partnership between Databricks and Snowflake, shaping the future of dark data architectures. Don't miss don't miss out on this change to learn how these technologies are revolutionizing the big data analytics. Now, before we dive into our next session, I'd like to take a moment to ask you for your support in helping us grow our community and recognize the speakers. Firstly, if you enjoyed the content we're providing and want to stay updated on future events and talks, please consider hitting like and subscribe buttons below this video. Now for something a bit special, in the video description below, you will find the link to the talk page where you can provide your feedback on this talk, give speaker a badge, and rate the session if you like or if you don't like it. Through the session talk, Through the session, if you have any burning questions or insights you'd like to share, don't hesitate to type them in the chat in YouTube or via community platform. Our team will be monitoring chats closely and will collect all the questions to discuss with the speaker after the presentation. And now, ladies and gentlemen, welcome our speaker to share his insights with us. Sridhar, floor is yours.
Thank you, Alexander. Hi, all. Welcome to Winter Data Meetup 2024. Today, I want to cover on the topic like Lakehouse evolution and like diving deep into Databricks, Snowflake, and next-gen data architectures. So last year, I have covered on introduction to Snowflake in Winter Data Meetup 2023. So this is kind of a sequel following the previous session. So to start with, I will introduce myself. Just one second. Yeah. So to start with, like I want to introduce myself here. So like I'm Sridhar Pothamsetti, working as a lead software engineer and data solution architect and consultant for the implementations I'm working with my clients. I have total 14 plus years of experience in IT industry and 3 plus years in EPAM. My work is like mostly I'll be leading and architecting the solutions related to cloud migrations and greenfield implementations. So my tech stack is completely like into the data engineering. So mostly on GCP, Azure, AWS, Snowflake, and the Databricks related implementations. I hold 10 plus active cloud certifications related to AWS architect, GCP architect, data engineer, digital leader associate, and Azure related certifications again related to data engineering and Databricks data engineering associate. So during my free time, I try conducting sessions to teammates or like friends and sharing the knowledge across, helping the people to grow and excel in their career. Moving to the actual session, so I want to first initiate explaining about the data warehousing and then the data lake and lake house, how they evolved. So initially the world, like when we enter into the data world, we start with the databases, right? So they deal with kind of GB uh, databases, right? So here, like there will be, we will be having a OLTP support, like transactions and all generally get supported, and then the data started growing in, and data warehouse started coming into the existence, right? So where we deal with the terabytes of data. So data warehouse will help you as a centralized repository generally, which stores mostly the structured data and maintaining the history of it and giving you the deep insights around it, right? So mostly it will be helping in the perspective of creating the reports based on the data you have, and also like giving the business intelligence around the data. So if we talk about the versions, mostly the storage and the compute are tightly coupled, and they support the structured data, right? So this is how the journey started. So over a period of time, the data started going, and then we moved into the world of Hadoop, right? And that is where the data lake came into existence, right? So in data warehouse, we'll be extracting the data, transforming it, and loading it into our data warehouse, right? But in case of data lake, it is like a kind of a storage repository loading all your data, like raw data. Either it can be unstructured, structured, semi-structured. So in its native format, it will load it, it will store it, and it will help you to analyze the data later. So here the concept is ELT: extract, load, and then transform. So here, once we started maintaining all the data, right? But here the good thing is the storage is decoupled from the compute. If we talk about Hadoop initial days, right? So storage is into HDFS and compute is into MapReduce, correct? and then it supports all the data types like structured, semi-structured, or unstructured. Anything, it is able to hold and load the data. Okay. So now, when we started processing this data, we don't have a kind of transactional processing or updating the data in data lake. That is where we got started facing issues, right? So then the journey evolved to be something to give the best out of both data warehouse and data lake. Okay. So Databricks and Snowflake trying to come forward and provide a new hybrid architecture which will give the best benefits of like the cheap storage, okay, which is available in the data lake, and providing the uh, like transactional or like the fast high performance output through your queries using the data warehouse facilities. So that is where Lakehouse is evolving to be a combination of both the best things out of data warehouse and the data lake. So to go to the architecture point of view, so like this is how it is, like as I said, right? So we will be having a structured data, and then we'll be processing it with ETL tools, right? And then we'll be storing it into the data warehouses, and Power BI or like any visualization tools or like any business intelligence tools can directly connect to the data warehouses, and they can start providing the output out of it. Okay. And coming to the data lake, it's like as I said, we will be processing the structured, semi-structured, and unstructured data, and we'll be loading it using ELT, right? So extract, load, and then transform, so your data lake is ready. So then you start getting the best benefits out of it, right? You want to show the reports, or like you want to give the data to data science teams or like machine learning teams. So here, if you see, after loading the data into the data lake, if you want to do some specific processing, then you are doing again ETL on top of it and having a data warehouses built on top of it, and you are giving the output. Okay. So that the world evolved to be something like a kind of data lake handling all your data, but there are some problems here also, as we discussed. So then data lakehouse came into existence, as I said, combining the benefits, right? So it is taking all the data which is loaded in data lake. So you'll be loading all the data into the data lake, and then you started having a layer on top of it, like maintaining all the metadata and the governance layer, which is giving you the data warehouse benefits, right? So you will be able to store the data, you will be able to query the data easily, just like your data warehouse. Okay. Giving the capabilities of ACID transactions and all these things. Okay. So this is the high level architecture. And so Snowflake and Databricks are the kind of lake houses we are trying to discuss now. Where exactly they are complete lake houses, or still they are trying to become the lake houses. That is what we will be discussing now. So generally, if you start with the Snowflake journey, Snowflake started as a cloud-based data warehousing platform, right? So EDW 1.0 has a problem of storage and the compute got coupled, right? So they are strongly, tightly coupled. So now when it comes to the Snowflake, it became a cloud-based data warehousing, and it is allowing you to do the same things what EDW, Enterprise Data Warehouse 1.0, used to do. So here it came up with the new features like Snowflake, Snowpipe, Snowpark, and Snowside, giving extra benefits over the existing warehousing part. Okay. So Snowflake is mostly like kind of available for all the people now. They can simply don't need to manage anything, start using it. I'll cover best benefits in the next slides. And coming to the Lakehouse part, when I say Lakehouse, Databricks actually brought this hybrid architecture terminology. So actually, Databricks started as a data engineering platform completely, and then evolved to be a unified analytics platform now. Okay, it is like a kind of handling the simpler workloads and also the large scale data processing and heavy workloads also, and providing the benefit of having the machine learning also on top of it, that being the data engineering platform. So over a period of time, it brought into the concept of Delta Lake, okay, which will be kind of giving the benefits of data warehouse on top of the data lake, like updating the data and all these things, which made it came up with a SQL engine, which we call it as Databricks SQL now, which is exactly like our Snowflake. And then for the data governance part, they came up with a like a concept called as Unity Catalog, which will be controlling everything, being at the top of the system, and providing the data governance, providing all the benefits which the management get out of it. Okay. So here, these concepts, like these are the parts we discussed, right? Like Delta Lake, SQL engine, and Unity Catalog, all these turned Databricks into a lake house. So this is the again like the detailed view, I can say, at a high level, like what is the storage here, how the things are evolving. Maybe we can discuss about these things in the later slides also. But at a high level, Databricks Lakehouse is like maintained on top of the public cloud, like AWS, Azure, or Google Cloud, and having the delta lake features, right? Delta format benefits, provides you the benefits of ACID transactions and all on top of the existing data. And then you have a data governance layer in the form of unity catalog, maintaining the metadata of whatever is present in the system, providing you the catalog of the data, maintaining the quality, and then providing the security, and providing you the privacy and the compliance also. And if we start discussing from the compute perspective, we are having Apache Spark being at the backend for this one. It will be processing all your queries with MapReduce at its backend. And query interface is mostly like you'll be able to run the SQL queries, you will be able to run the Spark data frames, or like the Spark uh, SQL, whatever you want to run, right? So from the Spark perspective, you will be able to run all the things, and Coalesce and the SQL are the extra things available for us. And the workloads it supports is like kind of Databricks supports streaming analytics, and then the business intelligence things, and also the data science and the machine learning things also. When it comes to the Snowflake, it is almost there at this level only, but from the different perspective, right? If we are choosing again from the storage perspective, Snowflake also starts from the public cloud only, so it has its data layer in the AWS, Azure, and Google Cloud, and it behaves like a data warehouse there. But while loading the data, it collects the metadata, store it, and give you the benefits of all the data governance things we discussed. And for the processing purpose, we are like here we are using the virtual warehouses. Okay, so this virtual warehouse concept is there also in the Databricks, but when we are talking about the Databricks SQL, it also follows the similar concept. So query interface is mostly SQL in terms of Snowflake, but recently, or like over a period of time, they came up with a Snowpark which works like pandas data frames, and will process the data, and will give you the ability of doing the data engineering also, but it is not at there at the level of the Databricks. So also it supports different types of workloads, like it supports ML, and it supports all the data science related things, but with third party tools are the partners who are available. Okay, and it will try to do that, but it's not out of the platform. Moving to the next one. So this is something I want to explain in detail here. So this is the main agenda here. So if you see here, right, I'll start with the B part. If you see, there is a data lake plus data warehouse architecture. Okay, so before the advent of this lakehouse platform, generally we used to have different types of sources, take the data, load it into the bronze layer, then into the silver layer after processing or like cleansing the data, and then getting the use cases provided by the users, right? So we will be putting the business logic into the gold layer. Okay, so here in Databricks, you will be having the data available here, but to give the feel of fast analytics or like fast query processing, we had to dependent on data warehouse. So this is like one example we also followed in our project. So we had our final data warehousing on top of a relational database. Example is Azure SQL, or maybe you can have Cloud SQL from GCP or something like that. So like over a period of time, we started facing problem, okay, in the form of like lot of users querying the things, but it is not able to scale to the level of actual cloud data warehouses. So then we started a POC, like having some Snowflake here, and then we did a lot of things on top of it, taking the complex workloads, did a POC, and identified that Snowflake provided a good benefit out of the existing data lake which is on top of Databricks. So Databricks plus Snowflake gave us good benefits over a period of time, like during the POC. So when we visualize it for the next 3 years or 5 years, it was doing good. And next we started with Synapse POC, and Synapse POC couldn't be completed in the stipulated amount of time given. But later when we moved to the Databricks SQL, that also was completed in the given time with the given workload, and they are able to show the benefits over the Snowflake. So Databricks own over a edge, okay, providing the Databricks SQL as an alternative to the Snowflake, provided the complete platform. in the Databricks only, and also considering the performance and then the cost and also the SLAs based on our workloads. So we started something like in the data lake plus data warehouse architecture, and now our client moved to the complete data lake house architecture here. So if we see here, like data sources are available. Data Lakehouse is completely having everything in the Databricks platform itself, like bronze layer, silver layer, and gold layer, and we can directly connect to the Databricks SQL from Power BI or like maybe Tableau. I'm taking some names because those are like very well connected to the most of the people, but you can use any tools here. Okay, so this is the actual world now where people are moving towards, like leaving the layers behind, having multiple things. And also, like if we have to use Databricks and Snowflake one after the other, right? So the problem here is you need to maintain the license cost of the both the things. So that also depends, and we need to go ahead, analyze the things further, and then need to choose the things accordingly. I will come back to these points in the later versions, later slides. So this is some data lake house platform completely. As an architect, right, when we are looking into the things, we'll be having a complete picture of how we will be processing. So if I have to explain at a high level, you have a different types of sources available here. You want to pull in all the data. You can ingest the data using Databricks, and if you are example on Azure, you can use the Azure related tools like Azure Data Factory, which is like orchestration or even ETL tool also. And you can have logic apps or the Azure functions, which also will help you to bring the data. Okay, so you will take the data, load it into the bronze layer, have it cleansed, and then have it like applying the business logic, you will be creating the gold layer here. So as I said, here you can have a Snowflake data warehouse, or you can have any other data warehouse available in this zone, and you can connect to the final business layer. So we started analyzing Snowflake data warehouse as an alternative to our Azure SQL, and then we completely moved into the Databricks SQL after identifying the benefits. So these points are important when we are concluding the session, so I will come back on this thing once again at the end. Also, from the DevOps pipeline perspective, as we are using Azure, we have used like Azure Active Directory, or like maybe from the monitoring perspective or App Insights perspective. And also, as I said, right, Databricks provides the Unity catalog, okay, which is helpful from the data governance perspective, but that is limited to the Databricks level only. But if you want to see everything from the Azure level, then Purview is something again like a data governance tool, which is on top of the Databricks. So if you are using Azure Cloud plus Databricks or maybe Snowflake or Synapse, whatever it is, so if you want to look at from the data governance perspective, so Purview is something which will help you to give the complete picture from the holistic perspective. Moving to the next one. So this is like highlighting the Snowflake as a query engine in the final layer. So if you see the same thing, and as I said, ours is like a kind of Databricks being the data lake, and then we analyzed Snowflake as a data warehouse layer, like reading the data, having the metadata collected, and having the external tables created or material residues created, and then reading the data from the Tableau and Looker. So here, as part of the POC, it also performed well. But as I said, right, over a period of time, we need to see like for how many years our workload is being looked into, or like what is our business vision. Like company is looking at some long-term perspectives, and then we need to take all those things into consideration and decide. So that is where like those Snowflake provided at a good level, we had to move ahead with the Databricks SQL. So when we are discussing about these things, we need to go deep on the features of each and every service, like maybe Snowflake providing something and Databricks providing something. So we'll start with, so this gives the like detailed things. Okay. So to start with, from the service model, Snowflake is completely software as a service, which means like you will be getting the account, you will log in, and then you can start working on it. It is like a completely fully managed service. There is no administration, or like there is no maintenance you need to do. Okay, only drawback here is like we don't have a control on the node types, because software as a service, it is trying to hide the type of nodes we will be using, or like they are unknown to the people. Okay, and we don't have a control on like whether we can modify or cost optimize those nodes also. Okay, but from the maintenance perspective, or from the scale up and scale down perspective and tuning perspective, Snowflake is taking care of all these things internally while loading the data itself, compressing the data, ingesting the data in a columnar format, and having the things collected, like metadata will be collected using the foundation DB. Okay, and have all those things available for when we are doing the queries. Okay, so it will be giving the better performance out of it. And when it comes to the Databricks, it is actually a platform as a service. Okay, and it's not fully managed, like most of the things are managed here also. But platform, being a platform as a service, it is giving the control to you, like how we can control the things, or like how we can customize. So maybe I want to get the nodes of like kind of 4 nodes. I need a cluster of more power, I need a cluster of more size, so then that is possible here in Databricks. So we will be having a complete control over the compute what we are using. And Snowflake is created as a SQL data warehouse, right? So cloud data warehouse. So the main aim, or like the main focus, is on the persons who already know SQL, which is like a data analyst. So data analysts who are already working on similar platforms can be easily what I can say, migrated to Snowflake, or they can easily learn the Snowflake. If I talk from the perspective of persons who is learning it new, so they will be easily understanding the things by going through the Snowflake sessions, or like going through the learn sessions we do have. And also for those who is having the SQL knowledge, it will be easy to catch up with the things. Okay, and from the Databricks perspective, it is aimed at the data analysts and then data scientists and engineers, because this is complete data engineering platform, came up with Spark and Python, Scala, all these things in the back end. So the persons who already came from the big data world, knowing all the things like programming for the map reduce, or maybe Spark streaming and all these things, so Databricks is something which is easy for those people to catch up with. So moving to the core competency, I think Snowflake is following a hybrid architecture also here, like a kind of multi-cluster shared data. Okay, so your data copy will be a single copy. Okay, and on top of it, like I'm from like kind of a data science team, I will have a separate virtual warehouse created, and I start querying the data. And some other person is from data engineering team, and he want to do like some queries on top of the existing data, he can do that. And another person from the data warehousing team, they also can query the same data. So that's why we call it as a multi-cluster shared data. Okay, and it supports mostly the use cases of data analytics, BI, and reporting. Okay, so it is aimed mainly on top of that, and supported languages are SQL, Python, and Scala. So as I said, right, Snowpark is using kind of data frames, right? So the syntax is completely into the Snowpark mode. It's not even pandas also there. Okay, but when you run it, it actually converts like to SQL in the backend and process it with the benefits of Snowflake. So it's not a pure replacement for the Spark data frames or the Pandas data frames. They get inspired from it and they started processing. So like if we go deep onto these things, we will be able to identify the difference between the Spark data frames and the Snowpark data frames. And from the Databricks perspective, as we already know that this is a Lakehouse platform built on top of the open source distributed processing framework Apache Spark, right? So it is like having a complete control for the data engineering loads, or like machine learning or streaming or data science related use cases you have. You can easily start working on it, taking these things provided in mind. Okay, and as already we know that Spark supports different languages, right? SQL, Python, or Java, Scala. So Databricks brought a collaborative way of querying the things using the notebooks and all. So that is a one extra thing which Databricks is providing. Okay, so collaboration is easy in case of Databricks for us. So moving to the data engineering setup, while setting up the Snowflake, we will be going ahead selecting the Snowflake account, okay, with cloud, maybe like AWS, GCP, or Azure. And we will be just logging into the system, and you will have a user friendly and the intuitive SQL interface to start with. So there is nothing like you will be setting up there. It's ease of setup is like very good for us, and then we can just start on top of it. When it comes to the Databricks, it also follows the similar way, but from the UI perspective, you need a learning curve because it gives more options. You need to understand like what type of node you need to use, what type of cluster you need to create, and then start working on it. And whatever Snowflake SQL interface and all it is giving, now Databricks SQL is also providing the similar format. But when it comes to the data engineering part of the Databricks, you need to have the collaborative workspace using the notebooks and all available to us. Okay, So from the data ownership perspective, Snowflake actually decouples the processing and storage layers from the scalability perspective. Okay, so when I say it right, storage can be scaled separately, and processing layer also, like virtual warehouses and all, can be scaled separately. But from the ownership perspective, like it is not completely decoupled. Okay, so it is targeting to do that in the future, like releases and all. But currently, it is like kind of doesn't decouple the ownership. The ownership of the storage and the ownership of the data processing completely lies with Snowflake only. So, and even Snowflake internal storage algorithms and all are not visible to any of the consumers. But from the Databricks perspective, it fully decouples the ownership of your data processing and the storage layers. And you can process data in any format, anywhere, including on-premise also. Like if you have if you need to migrate from different clouds, or like from the on-premise also, you will be able to create the mount points and all, and you can be able to read the data directly from the Databricks. Okay, so moving to the storage, as we discussed, Snowflake also has a data storage layer and then the cloud services layer. So here the data storage layer for both Snowflake and Databricks are created on top of the Azure cloud, blob storage, and then AWS S3 or Google Cloud Storage in the backend. And one better thing which Databricks has is, like, if we are using the Azure cloud as part of our implementation, Databricks is available as a native service. So like whatever the features you get out of the Azure internal services, those benefits you will be getting for the Databricks also, because it is a native service on it. And from the format perspective, as we discussed, Snowflake like processes the data if it is in structured and also in semi-structured. But from the unstructured data perspective, Snowpark started coming up with the data frames concept, right? So that is similar to Pandas data frames, but not exactly the Pandas data frames. Okay, so when you write the Snowpark data frames, it will get converted in the backend to SQL and finally processed by the Snowflake. And one open format is like iceberg format is available, just like delta format we have for the Databricks, and Snowflake supports the iceberg tables out of the box. And from the Databricks perspective, it will help you to load the unstructured data, semi-structured data, structured data, including audio, video, raw text, logs, etc. But like from the iceberg tables perspective, as Databricks is promoting its open source delta format, mostly it is able to read the iceberg tables and convert them into the delta format while processing it. And like while writing it into the iceberg tables, it is like not supporting currently as part of the universal format, and we need to wait and see in the future releases how they will be taking it further. So from the performance perspective, we might have already heard of the benchmarking wars happened between Snowflake and Databricks. So Snowflake says that it performed very well with the predefined data sets they have, okay, with respect to the data sets they have publicly made available, and they started running the transaction uh, performance council related queries, right? Okay, whenever we want to benchmark any of the services with respect to data, we generally go to the TPC DS datasets or like TPCH datasets, and we run it on the similar kind of infrastructure, and then we go ahead and compare the performance out of it. So when Snowflake ran its queries, they performed very well based on the data sets they have maintained. Okay, so based on that output, like it outperformed all the existing cloud data warehouses on query time or like the related cost during its time. But later, when Databricks did the same thing, like Databricks told that Databricks SQL is like a kind of processing the things very faster, and they came up as a record holder for their data sets. So this is a kind of, as I'm saying, right, one is trying to catch up with the other things, and Databricks is trying to catch up with the Snowflake related things. So Snowflake is from the data warehouse perspective on top, and Databricks is from the data engineering perspective. So both are trying to bridge the gap now. Like Databricks is entered into the world of warehousing, and Snowflake started entering into the world of the data engineering. So in future, we have to see how they will perform and catch up with the current scenarios. But from the performance, normal performance perspective, definitely for the SQL analytics workloads, Snowflake gives you the high performance, and Databricks, from the low latency perspective for the both batch and the real time, Databricks is giving the best benefits. So if we talk from the internal related things, right, and when we are loading data into the Snowflake, we will be loading the data using some like put commands, or like we have different types of stages available. While doing that itself, it will convert the data into a compressed mode, okay, and storing it into the columnar storage, and having the clustering done, having the metadata collected, having the caching being maintained, and have the optimizations applied while loading into it. And that gives the ability, because Snowflake has its own internal optimizations and everything done already, right? It will give you the high performance on your queries. Okay, so if it is simpler workloads or and not complex workloads, it performs very well. And from the structured data and semi-structured data perspective, Snowflake did very well on the structured data compared to the semi-structured data. It got a slowdown when it comes to the semi-structured data compared to the structured. Okay, and it's just like you, it will be don't need to do anything like in Snowflake. If your data is under, like if you have a table of 1 terabyte and above, then you need to do the custom clustering on from the user end. Otherwise Snowflake will be taking care of all these things internally. Okay, but when it comes to the Databricks, right, as I said, it has a customized mode of performance using like the Spark features we already have. And also Databricks came up with like Z order by, or like we have advanced indexing happening in the backend, caching provided for us, and hash bucketing is available, adaptive query execution is there. So whatever the customization we need, we have that. So like if we are having expertise on top of the Spark, if we have expertise on top of the advanced tuning techniques, we can take it to the next level with the control at the user's end. So this is from the performance perspective. And from the integration platforms and the dev tools, right? So both are like major ones in the market. So they already have good integrations with, or like the good partnership with multiple tools available. So if we talk from the Snowflake, they have good partners from the data integration side, business intelligence side, and advanced analytics side. And Databricks also has good integration with the data integration tools and the popular BI tools. I'll be covering that in the next slides. But Databricks, with the help of Unity Catalog, can run the queries on top of Snowflake in a federated mode. So that means Databricks can easily access the Snowflake in its environment if it is available. Okay, and also Snowflake can be easily connected, as we discussed in the previous architecture. So moving towards the Databricks partners, right? If you see, all the major partners in the market are already connected and they are acting as a partner, so you can easily connect and get the data, so based on your use cases. And from the data governance and security perspective also, we have major people from the market. From the data source perspective, we can connect and read the data. And from business intelligence perspective, we have Power BI and QuickSight, Looker, all the major like major tools, or like major service providers are already partnered. So like if you want to use Databricks, so it is easy, because if you have some things in already in your environment, you can slowly migrate it, or like you can work in connect with the existing tools also to start analyzing the things. So coming to the Snowflake, it's again like a kind of rich partners set we do have from the data integration perspective. Whatever we have saw in the Databricks partners list, so you see most of them here. Like from the business intelligence perspective or advanced analytics perspective, you see, right, Snowflake and Databricks are already connected. Snowflake can read the data with the help of Databricks, and also Databricks can read the data directly from there. And also security and governance perspective, we have Informatica, Alash, and Collibra, and all supported here. Okay, and SQL editors also, like we can use the corresponding SQL editors to connect to Snowflake and process the data if we don't want to use the cloud-based SQL. Okay, so we have SnowSQL, which is like a command line, and also we have UI from the Snowflake directly, so we can use all these things. Okay, and from the programming perspective also, we have Python, SQL Alchemy, Node, JS, and then the Go, .NET, JDBC, and ODBC. So this is the like a kind of rich partnership with the technology partners. So from the data sharing perspective, yeah, Snowflake initially started providing the data, and it can start sharing the data between different Snowflake accounts or different clouds also. It has the option. So how they will share the data? Okay, so you have a common data available, it will not be replicated, right? So you will be creating a reader account and giving the access to the team, and that team will be start reading the data from there, okay, without replicating it. So generally it should be set by the provider from the UI itself. Okay, and there is another concept called as data marketplace, where you can create a set of data sets, or like the processed data sets, and you make it available for the private teams or the public also to monetize it, or like without monetization also, but you can make it available for the people to use. So here, while sharing the data, it is done securely and without replication, as I said, which is most important thing, and it is compliant to the GDPR also. Okay. And when it comes to the Databricks, they came up with a open source based sharing concept, which they call it as a delta sharing, and it supports the delta sharing between Databricks to the Databricks accounts also, and Databricks to the non Databricks accounts also. So this is one of the best feature which Databricks is providing as part of the Unity catalog, uh, compared to the Snowflake, because it has a world green approach. So Databricks is giving good service from the delta sharing perspective. And again, as I said, both are evolving. They are trying to catch up with each other. If you see the service in Snowflake over a period of time, you see that in the Databricks also. Or if you see something in Databricks, it's being done in the Snowflake. So as I said, data marketplace is exactly similar to our Snowflake data marketplace, right? You will have some data sets or assets, tables, notebooks, or anything created, and you can start making it available for the people. So data marketplace of the Databricks is somewhat mature. Reason being, it has the benefits of sharing the models and notebooks and the dashboards also. Okay. When it comes to the Snowflake, it's kind of restricted to the tables or the objects of the Snowflake only. And data science and machine learning capabilities, as I said, right, Databricks is made out of the data engineering platform, giving the flexibility to connect to the data science team or like machine learning team. And as a data lake, being started as a data lake, it has its inbuilt things already supporting these things. But Databricks came up with MLflow, AutoML, which are like kind of helping you with low code, faster deployment models, and MLflow being the MLOps program, which will help you to deploy the things easily. Okay. And from the perspective of latest generative AI kind of thing, Dolly is something which Databricks is providing to us, and already they integrated with the existing platform where we can ask like generative AI to give the code whatever we need in the Databricks. So it's already available. So also from the Snowflake perspective, it is trying to catch up with the things as Databricks is, but it is relying on the third party tools which are available in the market. So as I shown in the partnership list, right? So there are a lot of plenty of partners where we can connect with the Snowflake and we can start processing the machine learning things. But I think Snowflake Cortex is something which is in private preview. As I said, this might be completely made generally available in the future, but this will help you to analyze the data and build AI applications on top of the Snowflake. So from the pipelines perspective, if we discuss, right, so already we discussed that batch data is being processed. Like we will ingest the data, we will like process it further and have it available. But from the continuous data processing perspective, Snowflake has a concept called as Snowpipe. You can create the Snowpipe and you can start reading the data from the cloud storage, okay, integrated with Snowflake using stages, and you can do the event based real-time ingestion. Okay. So here Snowpipe enables you to do the near real time or the real time processing, which is not exactly pure real time, I can say here, but it will try to give you the continuous streaming mode of loading the data and having the pipelines being run in the environment. So here Snowflake can ingest the data from public clouds like public cloud storage like S3 or like Azure Data Lake Storage or Blob Storage, and then you have Google Cloud Storage. You can have the storage integrations created, and then you can start reading them using the Snowpipe. Okay. So when it comes to the Databricks, it's the similar scenario here. Databricks came up with the autoloader. Okay. You need to create like spark dot read dot format, and you can give the cloud files. Okay. And then it will be configured with the locations from where it need to read the data, and it will start reading the data incrementally. So like maybe for every few seconds it keep adding some files into the cloud locations, then Autoloader will enable you to read that data and process it further with the next level of transformations you add to your pipeline. So Databricks can ingest data from these public clouds again, public cloud storage again. And one more good thing Databricks has is Delta Live tables, which will enable you to create a pipeline in a declarative mode, reading the data in streaming mode and having it running with data quality also added into the declarative language. So you can create a Delta Live pipeline and leave it running, and it can continuously run for you. So this is a automated way you can have it enabled. So Delta Live tables is one more thing which Databricks is providing to us. And when it comes to the Snowflake, from the orchestration perspective and all, right, we have tasks and streams, so we can use those streams and the tasks to have the things orchestrated and scheduled here. Okay. Moving to the BI and visualization, as I said, Snowflake has already good BI partner list, so we can connect easily and we can have our visualizations and everything being done. But from the Databricks perspective, it has a built-in BI functionality. So based on the data, you can create your basic dashboards or the reports you want to create. But it is not the strongest feature like Power BI or Tableau, which are mature tools in the market. But we can start with, and I think over a period of time they will be making a difference out of these things. So what I want to say here is like BI functionality is like available natively from Databricks to start. And from the data governance perspective, as I said, Databricks made a big difference with the introduction of Unity Catalog, providing like the lineage or like maintaining the data assets, providing the data discovery, controlling everything from a uh, centralized mode. Okay, having the admin providing you the controlling the access from centralized mode to the fine grain level access. Okay, and also maintaining the auditing of who is changing what. Okay, which we used to take care in Oracle and other things, right? We used to monitor everything like that. Now we got that functionality into the Databricks. And also, as I said, lineage tracking is something which will show like from which table, which column you are reading the data in landing layer, and then you are processing it into the next layer, like kind of uh, maybe gold layer or like silver layer. So the lineage, complete lineage will be available to you. Okay, and also the discovery of the data and AI assets is available by searching also, or like through the lineage you can check it. And delta sharing is something which will help you to share the assets, as we already discussed. From the Snowflake perspective, it also maintains the similar things, but from the lineage perspective, it is maintaining it in the tables, but not the UI based version is available. You need to connect with the third party tools to have the lineage made available, or like a lineage being shown as a graphical format, something like that. And from the collection of the metadata perspective and managing and discovering the data sets perspective, have like native catalog in Snowflake, and you can utilize it. And also Snowflake is providing the column level security, row level security, object detection, tag based masking policies, which will help you to maintain the security things, right? So you don't want to show all the data to the end users. Maybe you are a global team, but you want to show the data from India to India team only, and you want to show the data from US to US people only. So all those things can be controlled using these options available. Like in Databricks also we have similar things available, and we can use them. Okay, and data classification is also something which is available in the Snowflake. So from the data governance perspective, both have their own things being taken care. And like they keep on adding the new things with their journey with every release. So these things keep changing over a period of time. So in 2023, when I gave the winter data meetup session, there are like completely different portfolio for all these things. And now if you look at, there are a lot of features added, and now these are like a mature data platforms. And additional features perspective, Snowflake has a limitation of what I can say auto scaling to 128 nodes only. And I think there are like extension to this one to move to 256 and 512, which are in private preview. Maybe they will be made available in next features, right, or releases. And fast zero cloning is something like when you want to create clone, it will not copy any data, extra copy or replication of it. Okay, the same data is available, but you can create a clone on top of it, and multiple people can start working on the same data set without replicating it. And time travel is something which will enable you to like if you have some problem, somebody deleted your data in production, or somebody deleted your data in your test environment or something like that, then you can go ahead and revert it. Okay, you can go back in time, you can have it made available by storing the data. Okay, so this is a good feature, but it is not available completely in all versions of Snowflake. So Snowflake has different editions like enterprise, virtual private Snowflake edition, and then standard edition. So there are some limitations here, but from the Databricks perspective, it supports auto scaling without any limitations. And also with the advent of the delta table format, right? So here we got the deep clone and shallow clone. Deep clone will create a deep copy, and shallow clone is similar to your zero copy in Snowflake. And time travel is something which works similar to the Snowflake only, but without any limitations of editions and all. And now we entered into the final part of how we will be deciding the things, right? So when you want to, as an architect or as a delivery manager, you want to analyze Snowflake and Databricks for your implementation, right? So the first questions we have to ask is like, what exactly you want to do now, and what are you planning to do with your data. So we need to be very clear with this one. And the second important thing is what are the skills you have in your company or in house, right? So maybe like I have a team who is very good at a SQL. I have a team who is good at very like programming, or I have a mix of people, right? So this plays a major role in taking the decision on like what things we can do as part of our implementation. So if we have the answers to the above questions, so then we should be moving towards the next part, like how much do you plan to analyze, like how much data you want to analyze, or how much data you want to store. That also makes difference, right? If you have a simple workload, I have some maybe 1 terabyte of data, then it is small workload. If you have maybe some 100 terabytes of data, then it makes difference, right? And similar to that, whether you need the batch jobs only, or you have maybe real time or near real time data streams, so then that also is important. And how complex are your transformations are, like these are like kind of basic ones which you can run with SQL, or like do you need a complete control like creating the user defined functions, or like coding through Scala, Python, or like a highly complex processing is needed. That also differs, right? So we need to decide on which thing we want to do. Okay, after making a checklist on all these things, then we can proceed with our definition, sorry, decision. So are you deriving insights from the data streams, like you have a IoT, you have sensors, you have e-commerce platform which is giving you the click stream of data, or you have a social media data, you want to analyze that data. So this is one more question we need to be very clear, like at what speed we want to consume the data, or like how much data we want to process. So all these things make impact on your decision. Okay, and the last thing is, which is very important. Okay, like complete forecast I want to do is like a kind of maybe 3 years or 5 years. So in some scenarios 3 years will be suitable for some products, 5 years will be suitable for some products, right? So my company is aimed at a growth for 5 years, and from the expansion perspective also, like I want to look at from the 5 years perspective. Then like the product will change, like while choosing between the things, right? Snowflake might be doing better in like kind of 1 year perspective, 2 year perspective. When you are moving to the 5 year, that is becoming too costly. And from Databricks perspective, for 5 year, that is performing well compared to any other tools, right? So these things will help you decide which platform you need to decide. And these are some questions or the questionnaire you need to understand as an architect. If somebody is already designing their things, they are well aware of these things. But the persons who are not from the architectural background, right, they should think about, right, they might be moving towards that journey. So then they need to take care of these things. Okay, and conclusion, right? So concluding these things, nothing is like a kind of a best choice at any point of time, like. So but as I said, right, Databricks is trying to like match with all the requirements of all the people. But Snowflake is again competing there, right? And if you take the big lake, right, from the Google Cloud, or like Synapse Analytics, everybody is trying to catch up with the things, with the features they are provisioning, either by coming up with their native things, or interacting with or partnering with some other third party tools, right? So if we see, we generally when we want to conclude a platform for our things, right, so we should be assessing both the products, or like we want to compare two products. Example, in our scenario, we want to go ahead with Snowflake and the Databricks. So we need to understand our workloads, we need to understand the nature. Okay, and then we need to go ahead and implement the POCs with help of the partner managers from that companies. So like in our case, we contacted Snowflake, did a POC, we contacted Synapse Azure team, we did a POC, and then we went to the Databricks, and then we did a POC. Out of all these three, we saw the best thing over a period of time for 5 years or 3 years. We see the good benefits out of Databricks SQL being performing as a warehouse for us. Okay, so it depends on the workloads. Maybe if my project is very small and I want to go faster to the market, and with no headache of having admins or something, then Snowflake is best. So it is like we need to decide on what type of things we want to choose, what type of things we want to implement. Okay, so once we did the POCs, go through the analysis, go through the benchmarking, then we can select, and then we need to proceed with the implementation. So there is nothing like one thing will fit for everything, right? So we need to come up with our analysis and processing, and then only we can be able to decide. So based on the our implementation, or based on the few market implementations, so when we discuss from the perspective of data warehouse, Databricks and Snowflake both are able to deliver the things for us. And from the ETL, data science and AML perspective, Databricks is strong. from its capabilities, as it started from that level only. And if you want to serve both data analysts, data engineers, data scientists, so Databricks is your natural choice, and only data analyst, then you can choose between Databricks and Snowflake, again based on your vision. And from the ownership perspective, as I said, right, Databricks has the complete control of decoupling the things between storage and the clusters, or like the processing perspective. And from the data structures perspective, it supports all the three: structured, semi-structured, and unstructured. And from the Snowflake perspective, it supports both. Again, it is trying to catch up with Snowpark. We need to wait and see in future how that will evolve to be. Okay. And ease of use, definitely Snowflake is a winner here. And from the perspective of ETL and AML, again Databricks is the thing which is helping us. And from the query performance perspective, we have like small workloads being done good by both of them. And also from the big data, if it is huge, then it's Databricks which is winning because of the complex processing and the intense compute which we need. So integration platform and dev tools we have already discussed. It has a good rich platform for both. And data sharing perspective, if you want a proprietary sharing, so Snowflake data sharing is a proprietary one which is not available for out people. And data sharing is like a open source. So Databricks has like kind of open source thing being promoted with the help of delta format or data sharing and all these things, so which can be used by other people also. So Snowflake has some restrictions because it is not like in the format of open source. It is having its proprietary way of managing the things. Okay, so thank you, team. This is what I thought of bringing to you all, which will be helping for all the people who want to move towards Snowflake and Databricks. Okay, and also for the architects who are already working on, maybe I thought of giving the insights from our previous experience. Anything, sir?
Yeah, thank you very much, Sridhar, for your presentation. Very interesting. We have several questions. Yeah, maybe we can cover only one due to lack of time. So what's okay? You compared Snowflake and Databricks, but yeah, for data engineers, what will you suggest to learn, Snowflakes or Databricks? Because it's hard to
Yeah,
learn
yeah.
two things simultaneously.
Correct, correct. So generally, like as I discussed initially, right? So Snowflake is from the completely from the SQL background. So there are a lot of people who generally reach out to me, like, what should they learn, right? If they want to switch to the data engineering, I suggest if they are very good at SQL or like the warehousing knowledge, right? I suggest them to start with Snowflake, and over a period of time, they can start learning the Databricks because both things are similar over a period of time. And if they are very good at big data, they implemented some data lakes and they have good programming knowledge, they already know Spark data frames and all these things, so then we suggest them to go ahead with the Databricks. So yeah, this is something like helpful for their certifications, like both provide the good certifications, they can test their knowledge and they can help to grow in their fields accordingly.
Yeah, exactly. Yeah,
Yeah.
and I think that concludes our session. Thank you all so much for joining us today. We hope you found this session insightful and inspiring. In the video description below, you'll find the link to the talk page where you can provide your feedback for this talk, give Sridhar a badge, and rate this session. And also, if you have any questions, probably you have, just leave them in the talk page and Sridhar will answer them after the session. Additionally, if you'd like to revisit it, you can download the presentation file on the talk page or watch this recording. So check the video description for the link. Thank you very much, Sridhar, for coming. We could not do it without you.
Thank you so much, everyone.
Thank you.
Great day.
Goodbye.